Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing binary search. In this first pattern we have to do the next question, which is search in rotated sorted array. So let's read the problem statement first. It says there is an integer array nums sorted in ascending order. It is given, it is already sorted. Okay. Now prior to being passed to your function, nums is possibly left rotated at an unknown index such that resulting array will be okay. So it is saying ki our nums array will be sorted for sure, but it will be rotated by some k times, and we don't know what particular index till that it is rotated. Okay. So given an array of nums, after that possible rotation of an integer target, return the index of the target. Okay, you have to find the target in that rotated sorted array. So if you see here, if it was already sorted, then it should be 0, 1, 2, 3, 4, 5, 6, 7, right? But if you see, it has been rotated 4 times because 0 is at what index? From 0 to 4th index, correct? So if you see here, after one rotation, 7 will come from here, okay, and we'll add it in the beginning. Okay, now 0 will come at first location instead of 0. Yes or no? Yes. So now in the given example, 0 is at what location? 0, 1, 2, 3, 4. Okay. So after one rotation, 0 came from 0 index to 1 index. Then after how many rotations 0 come from 0 index to 4th index? Of course 4 rotations, correct? So hence this is also sorted, but in rotated sorted array. It means, what is the difference between normal sorted and rotated sorted? In rotated, it will be halfway sorted. So here is this index. You can say ki yes, right part is also sorted and left part is also sorted. Correct? Yes. And you can apply binary search? Yes, you can apply, but not on the entire array. Yes. Why? Because it is not purely sorted. Why I am saying this? Suppose your mid index hit here. Okay? Here. Mid index is here. So you can say from 0 index to here, this point, it is sorted. Yes, but you cannot say ki from 7 to this index it is sorted. No, 7, 0, 1, 2 is not sorted now. So you can say ki 7, which is a mid index, it is a part of left sorted array. So hence you can apply the binary search here. Okay, but suppose in some cases 4, 5, 0, 1, 2, 3, this one. Okay, let's say, okay, in this case the middle element will be 0 only. Yes, yes. So can I say ki from this to this, 0 is a part of left sorted array? If you see 4, 5, 0, no it is not. So can we apply binary logic here, binary search? No, we cannot apply. But if you see, 0 is a part of right sorted array, 0, 1, 2, 3, 4. Like 0, 1, 2, 3, yes. Now we can apply the binary search here. So the only difference here is, instead of the normal binary search, is you have to find which part is sorted because of the rotated sorted array. And if you can find which part is sorted, then you can apply the binary search. And now the condition is how you can find ki which part is sorted. Let's see. So in this nums array here, the index will start from 0, 1, 2, 3, 4, 5, 6. So we can find the mid index with the help of 0 and 6. Yes. Ki left pointer will be 0 index and right pointer will be 6 index. Okay. So similarly the mid index will be nothing but 0 plus 6 divided by 2. Correct? Left plus right by 2. But if you know this is not safe, so hence we always write like this. Left plus right minus left by 2. Okay, because of the constraint. What if the right index will be at its boundary, means 2 power 31 minus 1. So in that case, if you will use this formula, na, if you will add L plus R, so in that case R is already at its boundary, integer level boundary. If you will add a single number to it, it will go beyond that and it will become negative. Okay, so hence in that case we will not go with this calculation left plus right by 2. Instead we will go with this left plus right minus left by 2. Okay, so we will find the mid here, and what will be the mid index here if you will calculate 0 like 3, correct? Yes. So where is the third index? 0, 1, 2, 3, 4, 5, 6. Okay, third index is at here, like 7 is the number. So do you think left part is sorted or right part is sorted? But how you came to know that ki left part is sorted? Basically you have compared this number to this number, yes or no? Means if this part is sorted na, for sure your 7 will be greater than your left index value. Yes, because it is sorted. So definitely mid value should be greater. Yes. And if it was a part of right subarray, then definitely your mid value should be smaller than the right value. Why I am saying only left, right, mid? Because these are the only pointers which are known to us, correct? So if I know that this part is sorted, and at the end definitely the number will be greater, and if mid index is a part of right sorted array, okay, so if it was sorted, if this part was sorted, definitely it would be 7, 8, 9, 10 like this now. Then only I can say that 7 is a part of right sorted part, correct? Yes. But in this case, if you see, 7 is greater than the right element. So hence 7 cannot be the part of right sorted array, correct? Okay. So how we have found it? Let's write it also. How we have found it? We said ki if nums of mid means 7, if it is greater than or equal to what? If it is greater than or equal to nums of left pointer, then I am saying ki nums of mid is greater than this. So I can say yes, it is a part of left sorted array. Yes, yes. So now I can say कि this is part of like left sorted array, okay. So now we can apply the binary search here, or else if not, then in that case we will fall in what? Right sorted array, right sorted part. But in this case we know that 7 is a part of left sorted. So now let's try to find the target value here, okay. Now you will say ki this is sorted, but the target value is not there. Okay, we'll come to know how. So basically what I am saying ki even though this part is sorted, okay, but I have to find this target, and I can apply the binary search which is sorted, but it does not set ki 0 will be in the sorted part only. No. So basically I know this is part is sorted, and I will search if the target exists there. How can I search it? From the limit itself. Yes. How? Ki if the target lies in between this, so definitely the target should be greater than equal to the left value and less than equal to the mid value. Yes or no? Because I know these two pointers only na, and if 0 lies in between, then it should lie from this part to this part na. Yes. So I am saying ki if target is greater than equal to nums of left value, yes, and target less than nums of mid. Okay, so what I am saying ki if my target lies in between what? From 4 till 7, not equal to means less than 7, then I can say yes, it is a part of left subarray. Suppose the target was 5, okay, instead of 0, suppose target was 5. So you can say na, yes, your target lies between 4 to 7. Yes, so definitely you have to search, like you have to apply the binary search logic in the left sorted part, correct, because the target is also there only. Yes, yes. So if it was there, if it was 5, then what will you do? If this is the sorted part, your right is pointing to 2, your mid is pointing to 7, and your left is pointing to 4. So you want to search in the left half, correct, left half. So what will you do? Obviously you will move your right pointer to mid minus 1. Okay, why mid minus 1? Because it is target is not equal to na mid, so mid minus 1. So what I will do, if it is there, then we will shift our search towards left half and we will put mid minus 1. Else what we will do? You think? I said this is 0 now, this is not 5. So now if it is 0, so obviously it will not be in the left half sorted, even if it is sorted, but it is not here. So what do you think? We should put our search in the left half or right half? Obviously right half. Okay, so our left pointer is here, our mid is at here, and our right pointer is here. Now if I want to search in the right sorted part, what should I change now? Obviously the left pointer, correct? And where will I put? Can I put at mid? No, I cannot. No, because here no, I cannot, because if it was equal to mid na, before this if and else check, here only we will put ki if the nums of mid equal to target, we will return. But if we are in this if and else case, it means the target value is not matching with mid value. So hence we will shift our left pointer to mid plus 1. Yes, left pointer at mid plus 1. Now you will say ki this is so not sorted part, suppose. So now left pointer is here, right pointer is here, and now as you can see it is sorted, but you don't know na, when you moved your left pointer, you don't know ki this right part is sorted or not. Then now again you will go for the mid calculation and you will come to know ki okay, left part is also sorted, right part is also sorted. So because the left part is sorted 0, 1, so you will fall in this case and you will end up calculating the mid index in this case also, and again the mid index will be 0, and in that case mid index itself equal to target, so you will return. So I am saying we will write somewhere here ki if nums of mid equal to target na, then don't do anything, return your mid index then and there. Okay, then only go for this if and else check case. Okay, so this was to for left half sorted. Left means obviously in this case this part was sorted. Okay, now let's take another example. Let's take another example. Suppose 0 1 2 3. Okay, in this case left pointer will be here, right pointer will be here, which is the index 5, correct? Yes. Now here is the midpoint you will hit. Yes. So now do you think from left to mid it is a left half sorted? No, it is not. So where it is? It isn't. It is a part of, like mid is a part of right half sorted, correct? Yes. So now you will fall in this else case because this is not a left half sorted. So now you will fall in this else case saying ki yes, I found the right part is sorted. But even if the right part is sorted, what is my job? First find if the target exists in that right part or not. Okay. So what I will do in this case, ki if my target is greater than equal to, you say if 0 target is a part of this, so it should be greater than equal to this mid and less than equal to what? What? This? Yes. So greater than, not equal to. Why? Because equal to, so we have checked here only now. It was not equal to, then only we fall in this case. So greater than nums of mid and less than, like target, less than equal to what? Nums of right. If this is the case, we can say ki yes, our target lies in this half part, and because our left pointer is here, mid pointer is here and right pointer is here, so now I want to search in this right half part, so definitely I have to move my left pointer. Yes. And where to keep? Obviously mid plus 1, because if it was equal to mid, then to, if this first if case would have passed for this, correct? Yes. So definitely I'll put my left pointer at mid plus 1, else if this is not a part, you say ki suppose our target was 4. So even if the right part is sorted, but our target does not lie in this range, so definitely if not in this range, we have to search our target in the left half. Yes. And for that we have to do right is equal to mid minus 1. Very good. Right is equal to mid minus 1, correct? Yes. So this is the total code, and because we are calculating the mid index na, where we were calculating, so suppose I am calculating mid index left plus right minus left by 2 somewhere here. So definitely our left and right pointer are changing every time, correct? So we have to put in a while loop ki while left less than equal to right. Okay, why equal to? Because even if there is one single element, I still want to check ki what if that single element is equal to a target value, correct? Yes. If not, so coming out of this while loop we will return minus 1, because if you will see here in this case it is saying ki return minus 1 if it is not in nums. Okay, and if you will see the constraint, it is nums, like nums length is till 5000. So even if you will do the linear search here, so linear search will take O of n time complexity and it will be fastest only, correct? But if it is sorted, interviewer definitely expects you to submit the binary search code. So we'll start like int left pointer will start from 0 index and right pointer will start from nums dot length minus 1, correct? We want to start from the last. Now we'll start our while loop saying left pointer is until left pointer is less than equal to right pointer. Keep on running, because even if left and right pointer will point to the same index, means one point we have, we still want to look for if that matches with our target or not. Okay, now we'll calculate our mid index. So how we'll calculate mid? By left plus right minus left divide by 2, correct? Now first we want to check ki what if our nums of mid only, okay, matches with our target. Then we don't have to look for left search and right search. So we will return the mid index then and there, correct? Or else we'll go in if ki now if that is not like mid index is not equal to target, so we have to find ki left part is sorted or right part is sorted, correct? So how we can check ki if our nums of mid is greater than equal to nums of left pointer, correct? If that is the case, means for sure it is a part of what? Left sorted array. Left sorted array, correct? Or else if we'll fall in the else case, it means it is a part of what? Right sorted array. Right sorted array. Yes. Now if we are a part of left sorted array, like if the mid index is a part of left sorted array, so now we have to check ki is our target lies in between this, like ki if the target lies in between this, then to we can go for the search in the left sorted part, correct? So now what we will check, if it lies in between the left half, so how we'll say ki if nums of left, correct, should be greater, like should be less than equal to target, and target should be less than what, nums of mid, yes. If it is a part of left sorted array, then we have to move our right pointer to mid minus 1, okay. Otherwise, if target is not present in the left half, so we have to move the search in the right half, and for that we have to move our left to mid what, plus 1, yes. Now we'll go in the else case. We will go in the else case when our right part is sorted. So when our right part is sorted, we have to do the same if case check, but now not with left, with mid here, okay, not less equal to, less than, and target should be less than what, right pointer, correct. Now we can say ki yes, if target is a part of mid to right, then we have to search in the right half, and for right half we have to move our left to mid plus 1, correct, or else we have to go for the left half search, and for left half we have to move our right to mid minus 1, correct. Now after coming out of the while loop, if we have not found any such valid index, then we will return minus 1, yes, saying ki we have not found any like we have not found target in that array. Now we can run our solution and you can see it's passed. So now let's hit the submit button, and it has been submitted. All the linear search will also give you 100% because it is also faster. As you see, the constraint is very small, okay, 5000. But if the constraint will be so big, like 10 power 9 and 10, where linear will also fail, then you have to apply the binary search logic. And here is your Python code if you are from Python background, and here is your C++ code if you are from C++ background. So now with this we can go in our Rising Brain sheet and we can mark this question also to be done. And I hope you all have understood and submitted along with me. If yes, do let me know in the comment section saying solved or submitted. And if you really feel these videos are helpful for you, do like and hit the subscribe button, and you can even share with your friend. And if you're new to this channel, we are following the pattern-wise DSA sheet, and the link will be there in the description. And if you want to connect with me on any social medias like Instagram, LinkedIn, all the links will be in the description below. Do check it out. And that's it. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.